Happy day to my dear students. This is Nagarajan working as an assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering Trichy, accredited by NAC, approved by AICT New Delhi, affiliated to Anna University Chennai. So, the previous class we had a glance about the surface temperature measurement. Okay, in that apart from the measurement of systematic body temperature. Okay, in that we already discussed about this thermocouple. Okay, so couple, as I said, couple is two. Okay, when two dissimilar materials are joined together and that junction is maintained at a different temperature, then an EMF will be induced in it. Okay, that EMF induced is directly proportional to the temperature. Okay, now we are going to discuss about this thermistor. Okay, so this thermistor, okay, this thermal plus resistor. Okay, thermal plus resistor. Okay, obviously we know that the resistor is an semiconductor device. Therefore, this thermistor is also a semiconductor device. Okay, which is used grade, which is used in the measurement of temperature than the thermocouples. Thermocouples usually used in industries. Other than the industries, these thermistors will be used. Okay, for example, portable devices and in hospitals. Okay, or even in the places where the temperature has to be determined. Okay, for example, boilers. Okay, so these are the places where the thermistors are utilized. Okay, the thermistor resistance, okay, depends on the following parameters: resistance of the reference temperature. Okay, R naught is the resistance of the reference temperature. E is the, actually it is a natural algorithm. B, temperature coefficient ranging from 3000 to 4000. T is the temperature at which the measurement is taken, and T naught is the reference temperature in Kelvin. Okay, so selection of thermistor. How the thermistor has to be selected. Okay. First, physical configuration. Okay. Physical configuration, you can see it is an wire wound is there. Okay, and the air core is there, and ceramic type is there. So there are different materials. Okay, and how to select these different materials to according to their application, that is important. So first one is physical configuration. Physical configuration, as I said earlier, physical configuration of the thermistors. Okay, so here you can see it is an semiconductor device. Okay, it is round shaped and this is flat shaped. Okay, just like a small dot, and this is an coil type. So these are the different physical configurations. Sensitivity of the device. Sensitivity of the device in the sense how much the rate change in resistance happening in the measurement of temperature. Okay. Some may increase for 1 degree. It is based on the factor. Okay, based on the factor. Then resistance range and absolute temperature. Absolute temperature is the temperature at which the system temperature remains, and resistance range from ranging from 0.1 ohm to maximum 1 mega ohm. Okay, in some cases it may go beyond that value and below the value. So this is a range we are going to identify. Next one, problems associated with the thermistors. What are the problems? Okay, even when we are using the thermistor, this thermistor itself creates some problem. That is self-heating. Okay, self-heating. Self-heating is nothing but when the temperature is when the thermistor is placed in some hot environment, then before going to measure the temperature, it starts measuring or it starts reacting to the ambient temperature. Okay, and the current, yes, when starts conducting in the ambient temperature, then automatically it starts there will be a power drop in the thermistors. Power dissipation. Okay, what type of power drop will be there? Will be there in terms of milliwatt. Okay, how this can be overcome? The thermistor probe can be chosen correctly. First one is resistance range and sensitivity. Okay, these are the points to be considered for the problems associated with the thermistors. Okay, so next we are going to explain about skin temperature measurement. Okay, skin temperature. We all very well know that in the previous video we discussed about the skin temperature. Okay, that is what is the average temperature of a body. It is between 35, 36, 37. Okay, not even 35. It is above 35.5 and below 37. Okay, so what are the factors? First one, fat cover. Okay, fat cover in the sense there will be a fat beneath the skin. Okay, that fat cover will be acting as an temperature transfer obstacle medium. Next one is ambient temperature. Okay, ambient temperature. When we are going to measure the fever in desert, it is very difficult because already in desert there will be 40 degrees Celsius. Yeah, without keeping the thermometer into the patient, the meter will read 40 degrees. Then it is no use of measuring. So that is why the temperature is it is based on the ambient temperature. Then blood circulation. Blood circulation will also reduce the skin temperature. Okay, reason is when you are continuously doing some work, automatically you feel tired. Okay, because you are wasting your energy. So when you are wasting your energy, what is happening? You feel so tired due to sweatings. Okay, when you are doing work, your body is utilizing more amount of energy, and your body gets heated up. Then, in order to maintain the temperature of our body, our sweat glands is secreting sweats. Okay, so that sweating is due to the continuous circulation of blood beneath the skin. So that is this blood circulation will also reduce the temperature. Okay, so next. Probe used a small flat thermistor type probe is preferred in the measurement of skin thermometer. And now we are going to see about the non-contact type. Non-contact type. Now this non-contact type is nowadays very familiar due to this COVID, and it employs infrared thermometer. Okay, infrared light. Okay, so when the light is passed on the when the light is passed on when the light is falling on the surface, then it starts measuring the surface area, that is surface temperature. So if you have a chance to look at the glance of this infrared, not only our body temperature, it will measure the temperature of any object. It can be it can be the atmosphere, that is atmosphere in the sense ambient. It can be an object or it can be a metal, whatever it can be. Okay. Next, fiber optical type temperature sensor. Okay, it is a type of transducer that converts the signal to an optical light in the measurable form. Okay, so here the temperature is received. Okay, the temperature is received by the transducer, and that is converted into analog to digital signal, and that digital signal is transmitted. Okay, transmitted, that is to the through the optical fiber, and the receiver will receive the transmitted signal and then it decodes. Okay, decodes and amplifies the signal, and that amplified signal is again displayed. Okay, it's again displayed, or even we can have the printouts, whatever it can be. Okay, so that's all with the today's class. In the next class we will discuss about the blood pressure. Thank you.